Duplicate detection is a daily data quality task in ETL pipelines, like processing Kafka retry streams. This question tests if a candidate understands how to construct clean composite hash keys and optimize data matching. In modern data platforms, Kafka producers or message queues retry failed requests under network stress. Because of at least once delivery guarantees, these retry storms write redundant duplicate events into raw lakes. A vital data engineering interview question is to identify all duplicate records across composite key fields. Let's look at the naive double loop and why it locks up database pipelines. To solve this, candidates frequently write a double loop. They select a row, iterate through all remaining rows, and compare their composite values field by field. If they find a match, they mark the row as a duplicate. This nested scanning approach check n-squared pairs, creating an unsafe runtime bottleneck. This nested scan has an O of n-squared runtime. If your pipeline processes a batch of 10 million log records, it must run 50 trillion pair comparisons. The CPU utilization hits 100%, causing database lockups, SLA violations, and consumer connection timeouts. We need a way to check if we've seen a record without scanning the rest of the file. The optimal approach uses a hash set to store record fingerprints. We sweep the list once. For each record, we normalize the fields, build a composite tuple key, and query our set. In Python, set membership lookup is a constant O1 time operation. If the tuple key exists in the set, we flag the record. Otherwise, we add it to the set and continue. Single pass, O of n time. Handling real-world edge cases requires robust normalization. String casing like, click, and click must be standardized using lowercase. If your columns contain none values, you must map them to a static sentinel string to prevent false negatives or type collisions. Finally, float values like timestamp decimals must be rounded to a consistent precision to avoid floating point comparison mismatches. Remember the Hash Fingerprint Blueprint. When dealing with high-volume duplicate detection, never rely on quadratic scans. Normalize your input, construct a composite tuple key, and query a hash set in O1 time. This locks your runtime at linear O of n complexity and ensures fast, deterministic data quality checks. Let's analyze the brute force row comparison trap approach. Time complexity, O of n squared. Space complexity, O1. Comparing all row pairs leads to quadratic execution, failing on production scale transaction batches. Let's analyze the hash set fingerprinting correct approach. Time complexity, O of n. Space complexity, OK. A single linear sweep builds composite fingerprints, checking and caching them in O1 set operations. The interviewer will then ask, how would you design this for a distributed streaming pipeline with millions of rows per hour? Use a stateful streaming processor like Spark or Flink, partitioning the stream by a key field like user_id, and maintaining a state store with a TTL to deduplicate within a sliding time window. The interviewer will then ask, what if you must retain only the earliest record and discard later duplicates? Sorting the input chronologically first ensures the first seen record is preserved in the set, while subsequent arrivals are correctly classified as duplicates and filtered.